Good evening. I'm not sure that this video is going to make a lot of sense, and I apologize for that in advance. Hopefully, it will make a lot more sense after we've had a chance to work through the lesson together as a class. The note itself is pretty simple, and I hope, as I say, I hope by the time we've had the video and a lesson, it'll make a lot more sense. Let's get started. All right, the periodic table organizes our elements so that we can make predictions about them. This means that there's much less to memorize. Before the periodic table was developed by Mendeleev, the only way to study chemistry was to study all of the known facts about all of the known elements and commit them to memory. There seemed to be no pattern, no rhyme or reason, and it was extremely difficult to make predictions. So the periodic table means that we can learn a few trends and rules and general relationships, and that means that we can memorize less because we can predict more. It's important to note that the columns in a periodic table, remember columns are the vertical ones, columns are called groups when we talk about the periodic table. All members of the same group, that means all members in the same column, have very, very similar chemical properties. Let's have a look at 3 of those groups as an example. Let's have a look at group number 1. Some of the elements included in group number 1 are lithium, sodium, and potassium. Please note that even though hydrogen is often written at the top of group 1, it's not really a member. Lithium, the first element in the group, has 3 electrons. That means it has an electron configuration of 2,1. Sodium has 11 electrons, giving it a configuration of 2,8, as long as we're talking about atoms, of course. 2,8,1, I'm sorry, forgive me. Potassium has 19 electrons, giving atoms of potassium an electron configuration of 2,8,8,1. Note that all of these atoms will want to give away 1 electron in order to achieve a full outer shell. This means that they all want to make 1 bond. And that goes a very, very long way to determining the sorts of chemical properties that these elements will have, the way that they will behave in chemical reactions. Group 17 is way over on the other side of the periodic table, so members include fluorine and chlorine. Fluorine, for example, the first element in the group, has 9 electrons, giving it a configuration of 2,7. Chlorine has 17 electrons, or a configuration of 2,8,7. Bromine has 35 electrons, giving it a configuration of 2,8,8,17, because of course it's in the 4th period. We're not ever going to ask you to draw a diagram of bromine. If you cast your eye down the list, you will hopefully notice that all of these atoms will want to steal 1 electron in order to achieve a full outer shell. That means that they also make 1 bond, the same as group number 1 did, but they do it in the opposite way. They make a bond by stealing an electron instead of by giving 1 away. And finally, let's look at group 18 on the far right-hand side of the table. Some of the members of this group would include neon and argon. Neon, for example, has 10 electrons, or a configuration of 2,8. Argon has 18 electrons, a configuration of 2,8,8. Krypton would have 36 electrons, a configuration of 2,8,8,18. None of these atoms want to give any electrons or to steal any. That means that they make 0 bonds. All right, now that we've been all the way through these three groups as an example, there is one more term I want to define with you tonight, and we'll practice using it a lot in the days to come, and that term is valency. Valency is simply how many bonds an atom likes to make. So if an atom has a valency of 3, that means it likes to make 3 bonds. Likewise, an atom that has a valency of 1 likes to make 1 bond. Neon has a valency of 0 because it likes to make 0 bonds. And that's really it. So hopefully why we need to know this information will be a lot more clear tomorrow after our lesson.